Uh, Divyasri, Dipti,
Yes, sir.
ask them to join for the remaining of
Yeah.
this 6. So, yeah, please. Okay. Good morning to all. Yes. So in the last class, we discussed about the physical properties of oxide group of minerals, and before that, we discussed about the whole of the application of earth science or geology in the field of civil engineering. What are the applications where we are using this what we call earth science or a geology or a different rocks, study of different rocks, different minerals. Okay, and yes, the mineralogy study there. That is, mineralogy is nothing but is it's a naturally occurring substances, minerals, which are available in the nature, and it occurs as substances. It's inorganic, and which is having the definite chemical composition and internal atomic structures. Right. So these are all the perfect the minerals definitions. Okay, and right, what are the physical properties of minerals? So the first one is the color, habit, or form, and streak, luster, with the called cleavages, fracture, affinity, hardness, specific gravity, chemical composition, occurrence, industrial and economic uses, and magnetic attraction, and reacts with the diluted HCl. The last two properties are which are special. Some of the minerals like a magnetite, it attracts a magnet, and rest of the minerals will not attract the magnet. That's a typical property of magnetite mineral, and reacts with the diluted HCl, and these minerals are some of the like calcite or marble. So those who are having the rich of calcium, so it will reacts. Those are the things. So you understand. I hope you understand all this the properties. So it is the color. So varieties of colors will be there for minerals, and the next form is the it may be a radiating form, or it may be massive, or it may be called sheet like structures. Okay, different types of forms. Then when it comes to the streak is nothing but streak plate. There is a streak plate which is made up of with the the called ceramic raw products, right? So this is streak plate. It's just white color. I'll show you in the next class. And yeah, when you rub with the streak plate, it releases some color, the mineral. Most of the minerals are releases the same color, or it may be a different color. That's called a streak plate. And luster, that is a the shining of the minerals. Okay, shining of the minerals in surface of the minerals. Some minerals are shining, some minerals are not shining. Okay, those who are shining, we call it as a vitreous luster. Those who are partially shining, that is called a subvitreous. If it is a if it is not shining, that we call it as a dull luster, very dull. That's all. There are three classifications. And cleavages, whether it is a cleavage present or absent. Only two things you need to mention. So if it is a present, what is this, the significance, how it looks in the minerals, on the surface of the minerals. So it is in the just thin line of, like, fractures, hairline, thin hairline fractures will be there. You can easily identify when you have the specimen, hand specimen in the hand. Okay. And that is a cleavage present or absent. Okay. So fracture, there is a fracture in varieties of fractures will be there. Number one is even fractures. Number two is the uneven fracture. Third one is the concordal fractures, right? So even fracture means, so when you cut the mineral, when you break the mineral with a hammer, and what happens, it will break it in a proper, the shape. That is called a even fracture. When there is a cleavage present, and the fracture will be the even fracture. Okay. When the cleavages are absent, the fracture will be uneven. That is the logic. Because when there is a cleavage present, there is already the weaker zones, weaker zone in the what you call what you say that. Just a minute. Let me share the screen now so that you can go back to that. Yeah, I think I show the screen is visible now.
Yes, sir.
Okay, so there is a fracture, three types of fractures: even, uneven, and concordal fractures. Even fractures are perfectly, when you break the mineral, it will perfectly cut it. So uneven, it's abnormal breaking. It can break any day. Okay, and concordal fractures, that is called is nothing but it's curved shapes. It will come when you put the the small stone in the pond. It generates some waves. Just like that, it covers, it curves, it creates waves. It's like that. Okay, it's a concordal fractures. Okay, and diaphanity. What is a special character of diaphanity? Diaphanity is nothing but it is the ability of transmitting the light through the particular minerals. Say for example, quartz. It's a white, milky white, and what you call rosy quartz. It's a partially transferring the light. Milky white is 100% transferring the light. Okay, that's why we use this quartz for manufacturing of glass. Okay, and partially transmitting light in the quartz, it's a rosy quartz. It's a little bit partially transmitting. And smoky quartz, if you take it, it will not. Okay, so it's a what you call this transparent in the diaphanity, transparent, translucent, and opaque. Opaque is nothing but is not at all going to transfer the light. from one end to other end. Okay, transparent, one category. So next is a translucent. Translucent means nothing but it's partially transferring the light to the particular mineral. So next property is a opaque. It is called iron ore. It's not going to transfer the light anything. Then hardness, I told you that there are we discussed, we have already discussed in the last class the hardness, the most scale of hardness 1 to 10. Softest mineral is talc, and toughest mineral in the world, it is a diamond. Okay, diamond can be cut with a diamond only, no other minerals or metals. Okay, that is a hardness. Within the 1 to 10 the rank, all the more than 2000 minerals are discovered in the world. That comes under 1 to 10 hardness category. The chart, this is called a Mohs scale of hardness chart. Okay, that we have shown in the last class. Okay, that is a thing. And you can write exactly what it says, high hardness, low hardness, or medium hardness. That also you can write it. That is the best way. Instead of writing the specific number, it's very difficult to assess. Yes, this is a 6 hardness, 6 hardness, 7 hardness, 10. Okay, so instead of writing the numbers, you can write the in the words high, medium, and low hardness. That is the best way. And specific gravity is also same in the sense. So the some of the minerals are showing the volume is big, and when it comes to the weight, it's a very lightweight. So that things we need to feel when you get the the specimen on your hand. Okay, so specific gravity is low, medium, and high. The weight of the minerals. Some minerals are volume wise, the weight will be increased. Some minerals are volume is big and the weight is very less. Some minerals are weight is the volume is small, the weight will be the more there. Depends depends on the properties of the minerals. Okay, and so specific gravity low, medium, and high. Hardness low, medium, and high. This also you can write there. And chemical composition. But you remember this in the hardness. What is the most scale of hardness? The top 10 minerals that what we have discussed there: talc, gypsum, apatite, corundum, diamond, topaz, quartz. Okay, and corundum and diamond. All 10 minerals you need to remember that. Okay, so that you can easily remember, and you can easily answer for the questions when you get the physical properties of minerals. And chemical composition, it is the already well defined one. Okay, and occurrence. So the occurrence depends on the nature of the minerals, where it is occurring in the igneous rocks, sediment rocks, or in the metamorphic rocks. See, all these minerals are occurs in all three types of rocks. Some minerals are occurs in the igneous rocks, some are with the sediment rocks, some are occurs in the metamorphic rocks. Okay, that's why we call it as an rock is an aggregate of minerals, right? Some minerals, some rocks maybe only one mineral it's having. Some minerals it's having the more than one mineral. That is a different issue. So here is the occurrence, and occurrence of at different places, the geographical locations. Say for example, if you take the iron ore, it's in Ballari sector, Ballari, Hospet, Sandur, Chitradurga. You can write that. And what about then gold? Okay, Kolar gold mines, Hatti gold mines. Okay, what is the copper? Copper in Ingaldal in the near Chitradurga. Okay, if you take the all over India, and you can establish that iron ore, Karnataka, Goa, Maharashtra, and even in Chhattisgarh, Orissa. Okay, and copper, lead, zinc in Rajasthan. Okay, then potash mines in Rajasthan. So limestone in Karnataka, Tamil Nadu, Andhra Pradesh. So you can write that way. So this is the geographical locations on occurrence. Okay, and industrial and what is the economic uses, where we are using these minerals. If you remember, most of our in our routine life, we use these minerals. Maximum minerals we are using, knowingly or unknowingly. Now you are going to understanding that yes, which minerals we are using for the final product here. You of course knowingly unknowingly you are using the the minerals. Okay, some products you are using. What is the raw material for that? Where it is coming from, the raw materials, right? It's coming from the mines. And what type of minerals there? Say for example, if you take if you are using the the glass. It is coming from the quartz, right? So what about the irons? What we are using for the construction of the buildings, or a dam, or a tunnel, or a, what you call metros, or a roads, or it may be a reservoir. Where it is coming from the steel? It is coming from the iron ore. So where is availability of the iron ore? Okay, it's in the Karnataka, some parts, and rest of the the India, different parts of the in India. You can see the it's the iron ore is available, right? So that is a raw material, okay, and there is a processing plant, and we have the final the end users. We are all end users, okay. This is how the things. So knowingly, unknowingly, we are using almost all our minerals. I mean, some of the minerals we are using in our routine life. Okay, you are using the steel plates, steel, the copper, the stainless things. We are using the building wiring for the copper. It's from the chalcopyrite, raw material for that, copper and aluminum. Right. So like this, and we are using the as a civil engineers, you are using the the cements. Where it is coming from? How it is? You need the raw material to construct the buildings, confirm establish the infrastructure, right? You need the what you call road construction, tunnel. Almost all your civil engineering works, you need the raw material. Where is the raw material? Okay. So this is all the raw material coming from the mining sectors, and from mining sector to the refineries, or it may be a processing industries. From the processing industries, it goes to the end users in the market. That available sources, you are going to use it to construct the building. Okay, that you need to understand the first thing, right? And yeah, these are the economic uses. Okay, because we need, as I told you, that we need the minerals. So otherwise, we have to import the raw material. I mean, import the raw material, or import the final product, processor, the final processor product, iron and steel, for example, or cement. If you don't have enough resources in our country, we need to import the raw material, or import the final products. That cost will be the triple or four time of this current what we are using, the domestic raw materials, right? So this we need to understand. The first what you need to understand this thing is, what is the mineral resources, natural resources available in our country, because your work is completely depends on natural resources. If you want to take the highway project, you need the natural resources. Either it may be a water, or it may be your what do you say, this aggregates, or it may be a cement, or it may be water, or it may be a steel. Almost all you required the raw materials which are available in the nature, which are available in the earth. Okay, right. Your almost all projects are depends on your the raw materials. Your projects depends on the raw material. Of course, it is the final product which we are using, right? So we discuss these things and varieties of quartz. Okay, and the quartz, where it is available, how it is available. Okay, and yeah, this is a thing, and this is quartz vein, how it looks, the field, and yeah, varieties of quartz. And feldspars, we yeah, feldspars also we discussed there. And there are three, feldspar group, there are three minerals. One is orthoclase, plesioclase, and microcline. And all these three things are generally we use it for manufacturing of sanitary wares and earthwares. And also we use it for the porcelain beads, preparation of various glazed tiles and sanitary products manufactured from this feldspar group of minerals, because it it contains the potash feldspar, soda feldspars. Because of this chemical composition, it is very helpful for manufacturing of sanitary wares and the tiles. Okay, right. And when it comes to the, we discussed this mica group of minerals. It's because of high heat resistance. High heat resistance, we use this mica in electrical industries. Okay, generally this mica, it's very different colors, and its cleavage will be present. Fracture is a even. When the cleavage is present, fracture definitely will be even, because when you break the mineral, it will break in a proper position. The shape. Hardness is medium, specific gravity is medium. Okay, and chemical composition. Hardness is, you can write it as a very low, because it's a very thin, like a paper. Okay, right, and specific gravity is medium. Okay, chemical composition, you can see the chemical composition here: magnesium, iron, alumina, and potash. Right, so it occurs in igneous and metamorphic rocks. See here, the occurrence, if it is occurs in the any minerals, if it is occurs in the igneous rocks, maybe a high heat resistance, or the strength will be the high, hardness will be the high. Okay, this is how the things. Right. Okay, and the same thing for another type of mica. This is a muscovite micas. Okay, is it for igneous and metamorphic rocks? You can see rich of silicate of alumina and potassium. We have this. And mica powders are used in the mica bricks, steel plants, lubricants, filters in paint industries, rubber industries. Okay, and also it's in a plastic material, materials and wallpapers. You see the what are the applications, the uses which are very good in especially in the mica group of minerals. Because of this, silicate of magnesium, iron, alumina, and potassium, these minerals are used for this. And the bedded mica generally visit for lightweight concrete also this. See, we use this mica group of minerals because of magnesium content, iron, alumina, and potassium. We use in almost all the sectors like plants, steel plants, lubricants, okay, and filters in paints, rubber industries, plastic materials, and even wallpapers. Just to imagine that how important this, the minerals for your construction point of view as the raw materials supporting that. If there is no raw material, how you are going to construct the building? If raw material is not available, so how you are going to construct the building? That is a big issue. You need the raw materials. Okay, and do that too. What you call your the raw material should be the near. Otherwise, your project cost will be the high. The raw material sources are very near. The project cost will be less. Okay, everything depends on the market and geographic location where you are constructing the houses, or maybe the layout, or maybe the apartments, or maybe the any civil engineering projects like dam construction, tunnel, road, railways, okay, or canal. So the available the resources, raw material resources should be very near. Okay, right. And this one we have discussed in the last class. That is your that's called your most the core part of steel, iron and steels. Okay, so here the hematite, magnetite, bauxite, and corundum. Hematite is a massive that we discussed there, metallic cluster, because of it looks like a metal. That's why we call it as a metallic clusters. And magnetite also. Bauxite, it looks like a clay mineral. It's called earthy. And the corundum, it's a vitreous. It's a shining one. So all are medium or low to medium. You can write that. Okay. So specific gravity high, medium, and this is also high. And you can see the magnetite, hematite, Fe2O3, and this is a Fe3O4. Okay, and bauxite, it's having the aluminum oxides. Okay, and this corundum is have also iron oxides, aluminum oxides, and all are occurs in metamorphic, and you can see this sedimentary and metamorphic rocks. Here also sedimentary and metamorphic rocks. But in bauxite, it is occurs as an alteration product of alumina-rich rocks. Okay, and especially this bauxite, I told you that Maharashtra, Goa, Gujarat. So most of the products especially uses of manufacturing chemicals. Chemical industries, most of the chemical industries you can see from the Gujarat or in Bombay, that's in Maharashtra, and even from the some extent from the Goa, because you need the water and you need the available raw material very near to that to process this. Okay, and the corundum, it is generally used in the metamorphic rocks. It occurs as, and it's used as a gemstones, like a diamond. It's used as a gemstones. Okay, selling this, right? And this bauxite, and also we use it for the refining the petroleum. Where are the refineries? Petroleum refineries are there. We use this bauxite as a refining the petroleum. That is because of aluminum, the properties which is having in the, especially in the bauxites. Okay, so as I told you that, so almost all this our the products what we are using in our routine life. Okay, so one or other minerals, they took it as and process it and produce the final product. So here one thing I would like to mention that. So whatever the you are all end users. Of course, I am also end user here. Okay, but I am the first person as a geologist who discovered these minerals, because I am the end users, and also I am the the first persons who the food the like in the where there is an unknown place where the people are not roaming there, and we discovered the the minerals, maybe a hematite ore, or it may be magnetite, or it may be bauxite, corundum, diamond, or even limestones, or it may be a gold. So the geologists who are discovering the minerals all over the world, just keeping in mind. And then when the exploration done for 5 to 6 years or 8 years with a various mapping, geological mapping, geophysical survey, geological survey, and then identify the minerals and the chemical analysis, and then drilling part to know the subsurface geology up to 500 meter or maybe a 400 meter. Then we will do the analysis, strength of the rocks, rock quality designations, whether it is a hard rock, medium or rock, or it may be the highly weathered rock, or and also what are the chemicals, sorry, what are the the chemistry is there, whether it's a gold is there, copper, lead, zinc, iron ore. Okay, all those things we will assess from the drilling core, okay, which we recovered from the borehole. Okay, then the next step is that if the mineral is viable, economically viable, if you proved it, if you prepare the very good, the what you call this pre-feasibility and feasibility of this product, the project, particularly say for example hematite, what is the market conditions, what the market is required. So what is the price in the particularly the hematite price in the market. Based on that, we can assess that yes, this mineral is viable for extracting or mining to the present market scenario. That is called a feasibility report. Feasibility report includes your exploration results, and also the mining plan, and also the environmental impact assessment report. Along with that, if you are going to do the mining, if you are going to remove the waste from the mines, where you are going to put, how you are going to put, what are the adverse effect, environmental effect will be there. Okay, if you are going to carry out the mine, hematite mine, what are the environmental problems you are going to face it, how you are going to monitor it, how you are going to rectify it, how you are going to control it or minimize the environmental damages. So all those things we are going to put it in front of the government of India. That's called the Indian Bureau of Mines, and they are going to approve the mining plan. Then once you approve the mining plan, then what you call the mining engineer will come there. Okay, there is a resources. Company will recruit the mining people, mining engineers. So what we'll do, so they are going to, recruit the mining companies. They are going to recruit them, what you call the mining engineers, foremans, and there will be a lot of, the mining sector is completely, connected with almost all the departments. We need a mining engineers, we need a geologist, we need the, chemistry students. I mean, so it's called analysis part. We need the, surveyor, we need the civil engineers, okay, and we need the automobile engineers, we need the electrical engineers, okay, we need a hydrogeologist, we need, drivers, we need a environmentalists, we need a HR people, we need a marketing people also. And also it connects with, that's called forest department, ecology and environment, pollution control board, right? It's almost all the departments connects. So exploration for 5 to 6 years, geologist, and then comes to the mining part. If it's a feasible project is feasible, it comes to the what you call the mining engineers, those who are going to take out the, next step to extract the mineral from the earth, surface of the earth and subsurface of the earth also. Okay, and the next part, once you extract the mineral, it goes to the processing plant. Again, there will be a metallurgist, those who are processing the raw material. Okay, say for example, gold. If you are extracting, if you are exploiting, doing the mining from the, mines, it goes to transporting to the process mill or processing plant. There you are going to carry out the primary crusher, secondary crusher, tertiary crusher, and the grindings. And you are going to do some water washing, or you can 50% water washing, or 50% with a chemical washing, whatever the requirement of the particular minerals. Okay, and the next step is the final product. When it comes out from the the process plant, the final product, it goes to the marketing. We need the marketing persons there, and so when it comes to the market, we are all going to purchase it. So this is how the cycle of the what you call the mining. I am the end users, and also I am the first person to discover it, because I'm a geologist, right? So this is how the we are extracting or doing the mining from the earth, and we are producing the different final product for construction point of view, or it may be a road, or it may be any civil engineering project. Just to keep it in mind that you need the raw materials or the final products. Say for example, dam construction, you need the raw material for that especially, and you need the steels, you need the cement, everything you need. How it is? This is a process of getting the raw materials. Of course, you are going to get the final raw materials. Steel, if you want to steel, you can purchase from the shop. If you want to cement, you can purchase from the shop. So when it comes to the source, where it is coming from, how it is coming from, that you need to understand that. Okay, this is how the things, right? Yeah. So we'll go back to the the minings. Yeah. Yes, bauxite and corundum, right? And this is what all we have seen this, the mines, and this is specimens from the laboratory. Okay, and this is actual mines are happening like this, iron ore mines, right? And yeah, we'll go to the, okay, this is called a corundum. What we have seen there, this is a corundum. Okay, it's a granular, it may be a brown color, or it may be colorless. Okay, so all those things, it's just like gemstones. You can see this. See, as a gemstone, you can see the hexagonal or rectangular shapes are there. It's a totally different, typical one. And this is, we use it for ornamental as well as as a gemstones, ruby, emerald, diamond, and like a corundum, right? So all use it for as a gemstones. Okay, and yes, here is the we are using the the asbestos. So next, the group is that this Amphibole Group. Amphibole Group, there are two minerals. One is hornblende and another one is called asbestos. These two minerals are comes under Amphibole Group. So in the hornblende, what are the properties? Form, it's a columnar-like. Color is a dark green color. Streak is colorless. Diaphanite is opaque. Transparent light is not transparent. Luster is vitreous. Cleavages are present. Okay. Some minerals like, say cleavages are present, uneven fracture. That means there will be a, the mineralization, during the mineralization, there is a lot of variation in the cleavages. Okay. And hey, hardness is a medium, specific gravity is high. Okay. Some of the minerals, most of the, the 50% of the product, so the properties are same. Okay. Some typical, chemical composition, uses, or it may be a, form, and there will be, uses. Those things will be a varying from mineral to mineral. Okay. So here a chemical composition is a complex silicate of calcium, sodium, magnesium, iron, aluminum. You see this in the hornblende. What are the minerals are there in that? It's a complex silicates of calcium is there, sodium, magnesium, iron, and alumina is there, right? So it occurs in acidic igneous rocks and metamorphic rocks. So here again the igneous rock, igneous, sedimentary, and metamorphic, three types of rocks. Again the igneous rocks further we classified, that we'll discuss in the later stage, I mean the second model. But it is in the acidic igneous rocks only you can see this hornblende, okay, and metamorphic rocks. Okay, uses usually in the manufacturing of cement industries because of calcium, iron, and magnesium. To manufacture the cement, you need the raw material of calcium. How it is coming from? It's from the limestone that we discussed in the last class. That's the carbonate group of minerals: calcite, dolomite, and magnesite. Those are all we use it for manufacturing of cement, right? So here the hornblende, the availability is very less of the hornblende because we are not much using in cement, because the rich enough the calcium content is available. If it is available in the limestone, no need to the put again the hornblende into the cement manufacturing. Okay, it is just the analysis saying that it's calcium is there, sodium, magnesium, iron, and alumina is there. Okay, and we use it if required. We will use it cement plant. Okay, and it's also rock forming metals. And asbestos, it is a fibrous nature. That's fibrous nature. It's just like a thread. I'll show you the picture of this. And color, it will be gray, green, different number of colors. Okay, and it's a colorless. Stick is a colorless. It's a white or white or. And diaphanite is opaque, and luster will be the silky luster, silk like silk saris. It's a thread. It's like a thread. Okay, cleavages. It's a present, uneven. Okay, and here you can see this medium and high, and it's having the hydrous silicate of magnesium and aluminum. So especially in the asbestos, Assam districts in Karnataka and even Rajasthan, Tamil Nadu, and even Andhra Pradesh and Bihar, and the same thing for hornblende also. Extensive use for isolations, insulations, and manufacturing of lubricants and paint industries. You see this. So when we are using the paints, it is involved with the asbestos minerals. We don't know what are the minerals are there in the paint, right? So in the previous the slides, we were discussing about the that's called yeah. Here you can see this. The bauxite we are using. Bauxite we are using for the as in the paint industries or somewhere else, right? And refineries, yeah. So like this, the different minerals we use it for different purpose. Here you can see this. This asbestos in manufacturing of lubricants, the oil and the paints. When you are going to purchase the paint or something else in the the lubricants, you can just remember there will be a content of fibrous or this asbestos, because of magnesium and aluminum content in that particular asbestos. That's why we use this asbestos for manufacturing of lubricants and paints. And also we use this asbestos for what you call this sheet, manufacturing of asbestos sheet. Like nowadays we are getting the metal sheet with the tin coated. Why we are putting the tin coating on the metal sheet? To avoid the rusting. When you put them the tin coat on that, it will not rust it. Even it's exposed to the air, and even for the rain, nothing will happen. Okay, just like you are going to put the paint for the for your steel, the gate, or it may be where wherever the grills are there, so to avoid the rusting, right? So these are the things. This is asbestos mines. Yeah. And this is called actually the the bauxite one. Yeah, here is the asbestos. It's a white. Okay, see here you can see this. This is a white like a thread. Okay, you can easily find that how it looks this. And some extent it's looks like a dangerous when it enters into the lungs and all. You need to take care of lot this, because it's a very thread like a structures, and it it's a rich of magnesium and alumina, and it will be it's a health hazards. So you should not expose more of this. See, just like when you are going to what you call this cleaning your house, there will be a lot of dust. So when you are cleaning the house, what you are going to do this? So you are going to put a mask or something, the cloth on your face, or it may be nose and mouth, closing the mouth to avoid the dust. Same thing here also. So because it's hydrous nature, and if you use this inside your body, it may be a problems. Okay, because of its silicates. Okay, and here we can see this where we are using this some of the places. Okay. And yeah, when it comes to the hornblende, hornblende is a complex of ionosilicates series of minerals. Okay, and yeah, but the same name used for the field terms. Okay, amphiboles, calcium, so rich of calcium and sodium. Okay, and iron and alumina and magnesiums. Okay, and its color is black to green color. Okay, and gray color. Varieties of colors will be there. Okay, and yeah, so and hardness will be the it's medium hardness, 5 to 6 will be there. So this is how it looks, the hornblende. Okay, right, it's a black colors, and uses for this include the steel, soap, oil, building, and statue. But why we are using this in other things? This may be a small percentage. We are not going to use this type of minerals for 100% in the steel and all. Okay, if they really required for 1%, 0.5%, that time only we are using this, not all the times. It is a common component of many magnetic and metamorphic rocks, granite, cyanite, diorite, gabbro, basalts. You can get this amphiboles. Okay, and it's a rare kind of hornblende, contains less for 5% of iron oxides, and also it's green colors. Okay, almost all these minerals occurs in the all the rocks. Okay, generally hornblende we use it for crushed and used as a road construction and railway blast. What do you mean by railway blast? When you see the railway track, where is a lot of the varieties of rocks, or the aggregates, the bigger size, coarse sizes, the aggregates, or put it before the track, what you call this, fixing the track. So because of its the high hardness, generally we use this for this in the railway blast. Okay, it was cut as used as a dimension stones, high quality of pieces cut, polishing, and sold for the name of black granite. Also, you can use it. Okay, nowadays we are using all these things. Okay, and thus useful for understanding the crystallization of magma and for mineral research. This hornblende we use it for crystallization of magma. When the lava erupting, what type of crystallization is happening there, and also what type of minerals are going to involve. For that purpose, we use this hornblende. Okay, and yeah, these things we discussed there in the last class: calcite, dolomite, and magnesite. So here, what we discussed there, yeah, it's completely calcium-rich minerals except magnesite. Okay, and we use it for manufacturing of cement, refractory bricks, fluxes as a flux, as a metallurgical operations. Okay, and rubber paint industries. Okay, almost all the sectors we are using this. Okay, this is a cement. Sorry, the limestone mines are happening wherever. It may be a different shapes, different location, different shapes, and that depends on the different companies, and based on their manpower, based on the machinery capacities, based on the landscapes, based on the hardness of the minerals, hardness of the rocks, hardness, the overburden, total, the overburden, what you call the amount, quantity of the overburden, the shapes, mine shapes will be the different. It may not be the exactly same as this. Okay, right. And these are all the things. I mean, the what you call this? We use this magnesite, calcite, and dolomite. Okay, and yeah, this is the things called pyrite, galena, pyrite, and chalcopyrite. These are the sulfide group of minerals. Sulfides, in the sense, in the chemical composition itself, it can indicate this. PBS means lead. Pb means lead, S means sulfides, iron sulfides, copper, iron, and sulfides. This chemical composition itself indicating the whether it's an oxide group or it's a sulfide groups. When it comes to the what you call this carbonate group, this is all a carbonate group. See here, calcium carbonate, chemical composition, CaCO3, CaMgCO3, MgCO3. That means it's a carbonate group of minerals, right? So when you go back to the what you call iron group of minerals, yes, look at this here. Oxide group of minerals. It's called iron ore minerals. Oxide group. Why we are calling it oxide groups? The iron oxide, Fe2O3. It's also iron oxide, Fe3O4. And here also alumina oxides. And here also alumina oxides. See, that's why we call it oxides. Oxides group of minerals in the sense, it is exposed to the air. When lava erupting from the subsurface, it is exposed to the air. And later it was formed. Mineralization happens. Like a hematite mineralization, bauxite, magnetite, corundum, quartz, okay, or it may be asbestos, or it may be what you call this any other minerals if you take it. So asbestos, all those things, right? Right. Okay, this we have finished there. Right. Limestone mines, and here is the Galena. Oh yes, and here is the Galena. How it looks before going for the particular these things. Here you can see this, and Galena is lead of ore. Okay. Generally, we use this Galena for what you call Galena is the most important lead ore containing 60% of lead in the mass, and combined in the state of zinc and also used as a lead piping. Okay, lead piping. Galena, it's a crystalline. It forms as a crystallines, and color will be the red gray color. Okay. The slides are visible. Adhikeshav, Darshini, Deepti.
Yes, sir.
Okay.
Yes, sir.
So voice is also clear.
Yes, sir.
Oh, right. So, right. Yeah. Galena, pyrite, and chalcopyrite. So let's go with the only pyrite. Sorry, the Galena. It's a crystalline in the formation, and the color will be the lead gray. Okay. and the the streak will be the lead gray. Both are same, and luster will be the metallic because it looks like a metal. And hardness is a medium. Specific gravity will be the high. Chemical composition PBS. So occurs in a veins in sedimentary rocks. In sedimentary rocks, there will be another vein called veins. Galena, it will be veins. Almost all galena, copper, lead, zinc, gold. These minerals are forms in a vein types, thin vein. I'll show you that thin veins, how it looks thick. So it occurs in Rajasthan and Bihar. And Galena is the most important lead ore, containing 66% lead ore found and in combined states with the zinc and also used in lead piping. Okay, this is how it looks in the field. Lead ore, it's like iron ore looks like, but this is a one mineral. The volume is very small. Okay, when it comes to the weight, it's too heavy, too heavy. Okay, this is a typical character of galena. Okay, specific gravity will be the high. Okay, right. And when it comes to the lightest one, the rock called pumice rock, that occurs in the volcanic neck when the lava eruption is happening in the volcanoes, and in the surrounding of volcanic neck, it is available. That is called very light one, very lightweight, and it's a big volume also. It's when it comes to the weight, it's a very lightweight. So it's galena is in a reverse way. It's ulta. So volume wise, it's a small also. The weight will be the high. This is the typical character of galena. Okay, so these are the things, and yeah, let's have the small quiz on this. Okay, okay. So what are the the minerals available on the surface? How many minerals are available on the earth? Anybody can answer. Not exact figure. You can read the sound one. Darshini? Dasharath?
Yes, sir.
How many minerals are identified on the surface of the earth? Told you that this is more than 2,000 minerals, right? And yeah. So what are the uses of what you call this hornblende? What is the use of the hornblende? Okay, asbestos. Asbestos.
Insulation.
Yeah, insulation. Right. Insulations, and also for the asbestos sheet. Okay, and this corundum and all those things. Yeah, hornblende we use it for as insulations, and asbestos is also this, and manufacturing of cement. Hornblende generally we use it for manufacturing of cements and other products. Okay, and right. Okay, let me stop this.